Hello, everyone. This week we're talking about validity, reliability, samples, and surveys. So I put together a presentation, hopefully it'll be fairly quick, about 20 minutes I think it runs, and that will go through each of these in a bit more detail. We talked about this stuff last week, so it's not going to be new. We did talk about surveys last week, and I want to talk a little bit more about surveys. Some of you may choose to do a survey, whether you're doing qualitative or quantitative. Surveys can often be used. Quantitative surveys, of course, are very different than qualitative surveys. So what I'm going to focus in on is really going to be the quantitative aspects of surveys. Anyway, I'll go through this presentation, go through these slides, and we can learn more about them. All right, validity. We talked about validity last week, but validity really, when you boil it down, it just is, are you measuring what you think you're measuring? And are you actually going to be able to provide good, useful data that is a real direct connection to your research that you want to do and the hypothesis that you want to test, and ultimately back to the research questions and problem statement. So the process is to sort of state the hypothesis and state its null hypothesis, and then select proper variables that will allow you to test out your null hypothesis. If you do that, you're going to be able to then run your analysis and determine whether or not you're able to reject your null and accept your alternative hypothesis. That's all great, but we also have to continue to make sure that there's alignment between the variables that we've selected and the hypothesis we want to prove. Not just that, we also have to make sure that there is alignment between the variables we've selected, the hypothesis we want to prove, and the research that we've designed. And while it sounds like this should always be the case, it's very easy to get off track and see that the variables that we're looking at are actually kind of out of alignment a little bit with what it is we want to look at. Let's look at an example. This will make it more clear. So we have an example. I've got a hypothesis, and my hypothesis is that student satisfaction with instructors, with instructor performance, is related to the instructor's years of teaching experience. In other words, students are more positive towards the performance of the instructor if the instructor has been teaching for a lot of years. So the variables I have are student satisfaction and instructor years of experience. Now those two variables look pretty clear, but in fact the instructor years of experience, while it is a numeric variable and it is pretty clear, the student satisfaction is not clear. There are many different ways we could identify student satisfaction and many different ways we can define it. And that really comes down to researcher sort of judgment about how that's done. And it can be done however the researcher chooses to. It just needs to be clearly defined in the methodology section. So we're going to run a correlational analysis, and we're going to determine if instructor years of experience is the only thing impacting student satisfaction. So how do we measure student satisfaction? Let's get back to that conversation of measuring student satisfaction. We could use an end-of-course evaluation score. And that does seem to be a good indicator of student satisfaction. But again, what is the scope of satisfaction? An end-of-course evaluation score is really only going to be about that course. And it may be that the student is really not happy with his or her experience at the university, but loved a course. So suddenly we have an invalid measure. Or that the opposite, the student has had a great experience at the university and has had a difficult time in the course. Again, not a particularly valid measure of overall student satisfaction if that is what we're trying to measure. What could we use student retention, with the presumption being that if students are sticking around, they're satisfied? Probably not. That's probably not a good indicator, not a valid indicator of customer or of student satisfaction, simply because lots of students will stay even if they're not happy. They're about to finish their degree and don't want to transfer their credit somewhere else. If we have survey results and the survey is structured such that it is asking specifically what we want and it's very clear, then potentially we could use those. But again, it just points out that very subtle differences in the way that we're identifying student satisfaction can knock our research out of alignment with our original plans, our original problem statement and research questions. And so we just have to be really careful about ensuring that validity is accounted for in our research designs. Let's talk about reliability. Reliability is, in a sentence, getting the same thing every time, or getting similar results every time. So with reliability, we want to make sure that we're going to get similar results each time we run the test, or that we're going to get similar results when different people run the test. or we get similar results when we run the test with different populations. This really comes down to the way that our tool has been constructed. And if our tool has been constructed such that it is easy for the respondents to use, and it is clear, and there are a limited number of possible responses, and there's no terms that are ill-defined or not clearly defined, then we should be able to see fairly similar results across the different runs of the test. Here's an example. Imagine that I administered a test to 100 students, actually 3 times. So let's assume that I've administered a test of student skills to 3 groups of 100 students. And for the results in my first run, I get a mean score of 82.3 with a standard deviation of 7.5. So, okay. For the mean score number 2, I get a mean score of 87.2 and a standard deviation of 3.4. Those are a little bit different. And the standard deviation can be an indicator there. If they're very different, like they are for mean score number 3, where I have a score of 74.7 with a standard deviation of 4.8, there is very little likelihood that my mean score range is going to overlap with, for number 3, is going to overlap with my mean score range for number 2. So that might be an indicator that for some reason, for some confounding factor, whether it be a lack of explanation or some interpretation of the tool or use of the tool, the participants are reacting to it differently. And that questions the reliability. That makes me question the reliability of the tool because it's yielding such different results, even though it's run on what I presume to be similar populations. So one last bit about reliability and validity. A test can be reliable without being valid. In other words, it can return the same results over and over again, but they may not be the results that you want. So it's just returning the results on something, just it may not be what you're actually after or what you're trying to measure. However, a test cannot be valid if it is not reliable. And that's pretty often a problem. In order to have validity, we have to be measuring what we think we're measuring, right? And if the test is not reliable, then it is slightly changing each time or changing enough each time that it's not really giving us a clear picture of what we're after. So a test cannot be valid without being reliable. Talk about sampling. There are 4 common ways to sample. When we're talking about sampling, we are talking about the process of going to our population and selecting members from our population that are a representative sample of that population. So we want to make sure that when we do our sample, that we get as close as possible to a group that really represents what is in our population. And there are 4 ways to do that. There's random sampling, simple random sampling, there's stratified sampling, there's cluster sampling, and there's systematic sampling. And I'll go through each one of those. Random sampling, simple random sampling is just, you're basically just picking people. You go into your population, you're just picking people at random. So in that case, every member or every set of members has an equal chance of being included in the sample. There's a way to do this. You can use technology, random number generators, or some other sort of chance process to help you actually pick your random sample. A good example of this is a teacher who puts students' names in a hat and chooses them without looking at it to get a sample of students. That is a purely random sample. And it's good because random samples are usually fairly representative since they don't favor certain members. However, that only holds true if your random sample is big enough. And we'll talk about sample size in a minute. Stratified. Stratified is we're going to take the population first and we're going to divide it into logical groups that make sense. And then we're going to pick randomly members from those groups. So in that case, an example here could be at a high school, the student council survey could say, I want to survey 100 students, but I want to make sure that they represent all 4 grade levels. So we'll go ahead and select, first of all, we'll stratify them into freshmen, sophomores, juniors, and seniors, which they're already done, so that's easy. And then we'll pick 25, at random, we'll pick 25 from each one to get our sample of 100. But first things first, we divided them into groups and then we randomly selected. Stratified sample guarantees that members from each group will be represented in the sample. And so this sampling method is good. We want some members from every group. Cluster, again, we're going to divide them into groups, and they're going to be in whatever logical groups make sense for our research. And then we're going to pick a whole clusters. We're going to pick entire clusters. So that means that every member of a group is going to be pulled into our sample. An example here could be an airline company that wants to survey its customers one day. So they randomly select 5 flights. That's the flights, people being on flights is your clustering process. And then they randomly select 5 of them. And then everybody gets a survey. It's good because cluster sample gets every member from some of the groups. So it's good when each group reflects the population as a whole. And lastly is systematic. Members of the population are put in some order. So what we might do is we might order people alphabetically, or we might order them by age or something like that. And then we decide we're going to select every nth member. It could be every 10th, every 20th, every 5th. And so we just go through and systematically pick every one of those, and that becomes our sample. How big should our sample be? Well, that depends. Normally 30. You're going to hear, the more you're exposed to statistics, you're going to hear 30 over and over again. Sample size should be at least 30. And I've heard that from a number of instructors, and I've heard it from a number of textbooks. But there's some variability in that. If the sample that you have, if the population that you have is widely varied, then sometimes 30 is going to be insufficient. You can calculate a mean for a particular variable, but if your standard deviation is pretty large relative to that mean, then 30 may not be a good indicator of your population. It may not actually contain all the information you need to represent your population. You may need to go as high as 100 or even 160. If you do some work and find that the variables you're looking at have a very small standard deviation relative to the mean, you can drop a little below 30, maybe down to as low as 20. But you'd have to justify it in your research when you wrote up your research as to why your sample size is so small. The issue about knowing the sample size, knowing the sample mean, that is something we don't often know. We may be able to sort of predict it based on analysis that we've done with similar data sets, but we don't often know what the mean is going to be until after we've gathered our data set. So in our research design, we will probably have to go with a minimum number if we're going to do quantitative, a minimum number, and that is just safety. So we may decide that we're gonna need 30, and we're gonna have to do whatever we can to get 30 responses. That may be sitting down and talking directly to 30 people and asking them to fill out a survey, or it may be sending out an online survey and hoping to get 30 responses back. And I'll talk about response rates on surveys in a bit, but it is a very big issue since response rates on electronic surveys or even live surveys can tend to be pretty miserable. Let's talk about surveys. Surveys are often used, and they're often used wrong. And I bet everybody who is in this class has had the opportunity to, somebody's asked them to fill out a survey, and you're like, all right, I'll help them out. I'll fill out the survey. And then you get into the survey, and 15 minutes later, you're faced with the next page of questions. And it's hard to discern what's the difference between one question and another. And it's hard to figure out what they're asking. And that's why surveys are often done bad. When you're designing a survey, first thing you want to think about is what is it you want to know? And oftentimes that's going to be supported by the literature, because you may have a particular research question or problem statement, and you really need to ask your respondents something to determine what the trend is or what their feelings are. But you sort of have an idea of what you want to ask, but you don't know exactly. And so the literature can really help, because the literature can tell you this is the trends that we're seeing in a particular field. And if you want to build upon that literature and build upon that knowledge, then you can utilize that literature to help you construct your survey. When you construct a survey, you want to construct questions that are, first of all, valid measures of what you want to know. We've already talked about validity. You want to make sure that you phrase them in a way that they return reliable results. That means defining clearly all of the parts of the questions so that there's nothing left to chance and there's nothing left to interpretation on the part of the respondents. You want to field test. Field test. I'll talk about field testing a couple times in the next couple slides. But what field testing basically is taking your survey instrument once you have it constructed and providing it to people who could be in your population, could be in your sample, but aren't. They could be members of your population, ones that, if you did a random selection, they would have had a chance of being selected, but you're going to exclude them in your actual research, but they become your field testers. What that allows you to do is they can look at your tool and determine the extent to which they understand it, that it makes sense, and that it's not exhausting. You want to make sure that your survey is aligned with your problem statement and your research questions. So just keep making sure that you go back and you check your original problem statement research questions, and that the tool that you're using is in fact giving you information that will allow you to address those. That seems like common sense, but trust me, I have seen dissertations that got basically to the end and realized I forgot to ask about this in my survey. And so just you have to make sure that you're really clear and aligned. And then make sure it's relevant. Don't ask questions you're not going to use. One of the things I've seen is that surveys will often ask demographic information, even though it's not relevant in any way to the actual research questions. So, but still, there's some sort of kind of assumed obligation that I need to know, the percentage male, percentage female, etc. If it's not relevant, don't ask it. So here's an example of a survey of student satisfaction, kind of going back to the previous slide. What is a valid and reliable way to determine student satisfaction? Well, we can ask them. But when we ask them, remember, it's got to be clear. It's got to be well defined. You may even have to define it in the survey tool, and it has to be consistent. You're going to have to be able to sort of come up with something that is validly measuring what you want to measure in a reliable way. Another way that you could actually get student satisfaction information is you can use what's called extant data, and that's existing data. A lot of times for quantitative research studies, even qualitative research studies, there are data that already exist. Now, you have to be careful here because remember, in a dissertation, your job is to create new knowledge that furthers the field. So if all you're doing is going to a filing cabinet and pulling out stuff that's already there, that's not really dissertation worthy. But if you're able to get existing data, and then you're able to dig into that existing data and uncover information that nobody's uncovered before, there's no problem with using existing data. What you want to make sure that you're looking at, whether you're creating a tool or you're looking at existing data, is will acquiring or analyzing this data address one of my research questions or help me solve my my problem statement? And then make sure you analyze your tool. And in this case, with our satisfaction with the instructor, is the tool, is it valid? Is it reliable? Are all the terms like satisfied? Are they all clear? Have they been clarified? Is it aligned with your study? Are the questions phrased in a way that would be widely understood? And once again, I'm going to advocate for field tests. Field tests will yield you great information that you wouldn't normally get. Already talked about leaving out things that are not relevant. You want your survey to be as clear and defined and simple to complete as possible. So if you've got any questions in there that are going to give you information you're not going to use in your study, get rid of it. A good survey design, the purpose is clear. It is clear why I am completing the survey. I'm completing the survey because I'm helping research that will do whatever. So you as the researcher need to make that clear to your respondents. The questions are clear. So you've already done the reliability check and the validity check, and you've defined all of the terms in there that might be open to interpretation. The survey is short and to the point. No long pages of questions and no, surveys that are going to take 20 minutes to get done. And just make it quick and to the point. Surveys should be completed in 5 to 10 minutes tops. If you give them a giant survey that takes a very long time to complete, one of two things can happen. The respondent can just walk away and just click out of it and say, I'm not going to do it. Or the respondent can get to a point where they've given you valid responses for the first 15 minutes of the survey, but now they're like over it and they're like done and I want to move on. And so they're just going to click through and just click boxes to get the survey done. So make sure that you're quick and to the point and that you don't allow for survey fatigue to come into your process. And I've already talked about field testing. I'll make one more plug for it. Response rates on surveys are usually low, especially online surveys. And it's not uncommon to get 5%, 10%, 15%, 20%. That's great. That's a great response rate on an online survey. And if you need to get 30 responses, then you need to plan, right? If I'm going to have to get 30 responses and I expect that my response rate is going to be fairly low, that means I got to send my survey out to enough people so that I can yield 30 useful responses. Or if I need more, then I have to send out even more responses. Some of the strategies to get better response rates. Online actually will give you better response rates than a mail. I don't think anybody mails surveys anymore, but online is far better and far easier. Keep it simple and to the point. Somebody who sees a survey that is going to take them just a couple of minutes is more likely to complete it. Send out the survey and send out reminders. So send it out, the initial survey, and then if you can, remember the survey closes in 2 weeks. Please help me fill this out. And you also might offer a return for completing the surveys. Oftentimes, respondents are going to be interested in what you're researching. So you can give them, if you complete the survey at the very end, give them an email address, and I will send you the results. If you send me your email address, I'll send you the results. And so they would be interested in that. If you can indicate that at the beginning of the survey process, by completing the survey, you're helping me complete my research. If you like, at the end of the survey, you can provide your email address, and I will send you the results of the survey. You can also sometimes find a survey tool that somebody else has already created. And that's great if you can find a survey tool if it fits your research. I would advise you to seek permission from the researcher who created the tool. Sometimes that's possible, sometimes it's not. But if you can, it's an academic courtesy to ask permission to use the tool. In your dissertation, you would describe why you chose this tool for your study, what relevance does this tool have for your particular study. But don't force fit the tool. Don't force the tool to fit your particular study if your study is different, because that will cause problems with validity. So example here is you've got a research study you want to conduct. You've come across the literature that describes a particular study that's already been done. The tool was created for that study. It sort of fits what you want to do, but doesn't 100% fit what you want to do. But if you then force fit it to your particular study, you may be measuring things you don't want to measure, and you may be reporting on things you don't want to report. So just don't force fit the tool. Be sure to cite the tool's creator in your dissertation. You would do that anyway, of course. And any sort of literature that supports the tool, if you utilize it. Now, by citing the article and the author where the tool came from, you're sort of secondarily citing the resources that author used. But if you directly cite any part of that, then you should have that noted in your dissertation. In both cases, describe with supporting literature your survey design or your use of a pre-existing tool. What you're going to want to put in your methodology section is why did you design what you designed, or why did you pick what you picked, and what relevance does it have to your particular study. Indicate why you're asking what you're asking. Be clear about how you will gather the information. Now, most online surveys, that's pretty easy. SurveyMonkey will just provide you with reports that give you the results. But in some cases, it may be more complex. Indicate what you're going to do with the data that you receive, and indicate how well does it fit your study. Okay, last caution. Don't let this happen to you. I saw a dissertation one time that had a great survey. It was valid. It was reliable. It was clear. And it had a good response rate. Everything you'd ever want in a quantitative study that uses a survey. Problem is, when the researcher got to the point where they were evaluating chapters 4 and 5, creating chapters 4 and 5 where they talk about the findings and the meaning of the findings, they came to the realization that the survey, while it was valid, reliable, clear, and had a good response rate, did not provide what the original study was asking for. And then it's too late. Then you have to basically say this is a researcher error, and it becomes a huge issue. So don't let that happen to you. Make sure that when you design a survey, it is valid, reliable, clear, it'll get a good response rate, but most importantly, it is aligned with your problem statement and your research questions. Okay, that's it for this week. Let me know if you have any questions. You can hit me up via email.